Okay. So I think we're ready to go here. So we have three problems. I'm going to do the last one first. Actually, I'll do the second one first because the second one's really easy. Okay. It's 4/9 plus 7/9. Well, how many ninths do you have? You got 4 of them here and you got 7 of them here. That makes 11 of them. So that's equal to 4 plus 7/9, which is equal to 11/9. And if you want to make that 1 2/9, open math does ask you to do mixed numbers as well as improper fractions. I generally don't care much about the mixed number unless you're going to graph it. If you're going to put it on a graph, then you want to know that's 1 2/9. It's between 1 and 2 and a lot closer to 1. Does that make sense? Okay. So there is a point to the mixed number. And I prefer mixed numbers to decimal conversions in most cases. Because you got to know how to use fractions. Okay. And one reason you're learning to use fractions is that we do fractions with all kinds of algebraic expressions. And if you're not doing the steps, you're not going to know what the steps are supposed to be when it's unfamiliar. Maybe do an example of that after we go over these quiz problems. So the steps here should be 4/9 plus 7/9 equals 4 plus 7/9. Don't just write down 11/9 because you know that that's what happens. Write down it's 4 plus 7/9 because you have ninths. You have 4 of them here, you have 7 of them here, so you have 4 plus 7 of them here, and that's 11. Okay? If these are more complicated algebraic expressions, you're going to have to write it in this step. So start writing the steps right now. Okay? Be sure you write them all. And many of you are doing really well with that. The others are getting the right answers. They know what they're doing. But don't shortcut the steps. Okay? Okay, so we have 5/8 plus 2/3. And I say okay too many times. I look at my transcripts and every third word is okay with a question mark. I'm going to work on that. I mean, I've been doing these forever, but the transcripts are so good now that I actually can read them. Okay, I did it again, didn't I? 5/8 plus 2/3. What are we going to do with this? We can't say, well, I've got this many eighths and I've got that many thirds, so I'm going to have this many something. Do you have eighths? Do you have thirds? What do you have? You can't answer the question like you can here. You see the common sense of this. You're adding ninths to ninths, and you can do that. You can't add eighths to thirds without going through a little bit of effort. And what you're going to do is you're going to break them down both into 24ths because your common denominator is 24. Okay? Now and that's your least common denominator. Okay, well, I'm not going to go into all the detail on that because this is a review of 5th grade arithmetic. Okay, if you practice it enough, you're going to get it. And the one thing you want to absolutely practice is writing these things out with all steps. So you can put down here, put a question mark there. You don't know what it equals, but you know that the common denominator is 3 times 8, which is 24. And I did talk last time when the microphone was still working, so it's there on the video, about how you could use prime factorization to find the least common denominator. In this case, that is the least common denominator, so I'll put an L in front of it. So I'm going to write and I'll write it in the column here. How are we going to get 24 for the denominator here? We're going to multiply by something with a denominator 3, and that's going to give us denominator 24. Now, if we multiply this 5/8 by anything but 1, it's going to change its value. You multiply by 1, you don't change the value. If you multiply by anything else, you change the value. Well, we don't want to change the value. So what we better do is multiply by 3 over 3, which is just the same as 1. It's going to change the look of the fraction, but it's not going to change its value. In each case, if you did a decimal conversion, you'd have 0.625 either way. And for 2/3, we multiply by 8 over 8. And that step needs to be there. Okay? The reason it needs to be there is not so much I'm going to penalize you if it isn't, but I'll at least complain. And I'll complain because if you don't write that step, you aren't reinforcing what you're doing. Does that make sense? You're going to need this. So you want to get used to all the steps. Well, anyhow, that's 5 times 3, and I'm going to even write out this step. That's 5 times 3 over 8 times 3, because people confuse the rules for addition and multiplication of fractions. Okay? So we just reinforce the idea that we multiply the numerators and we multiply the denominators. And we're going to be more likely after writing that to do that correctly the next time, or a month from now, or 6 weeks from now when you have to do it with symbols, okay? So that gives us 15 over 24 plus 16 over 24, which equals, I'm going to write it all out even though I'm running out of space, 15 plus 16 over 24. That equals 31 over 24. And if you want the mixed number, that's 1 and 7/24. Okay? You see how many steps it's possible to write down for this. I want you to write down every possible step. Okay? And if you're not 100% on this, if you didn't get the first problem, now if you got it without writing out the steps, still do a few of them and write out all the steps. You really want to reinforce the steps. Okay? But if you didn't get the first problem, I'd recommend you go back to the open math assignment, the last one you did on order of operations with fractions, and rework them by writing out everything. Shouldn't take you over a half hour, at most an hour, if you know the steps, and if you don't, you need the time. This will be very important later, and it'll be very important in a pre-calculus class. Okay? I'm not requiring that you do that. And if you want me to look at your work, just take a scanner out, send me a PDF. Can everybody do that? Okay. Everybody have a scanner out? Phone with scanner out? Okay. For any distance students watching this, Adobe Scan. Okay. It's free. It works. A lot of people use it. And people use anybody using Adobe Scan? Yeah, usually get that. Okay. I'm going to pause for a minute. I want to know what people are using. There's some majority that's using something else. Okay. I just kind of polled people what kind of scanner they use, and it turns out that a lot of people said they had a scanner or seemed to say that, and then they said, no, I don't, but I have a smartphone, so I'll download one. You can investigate it. I know that Adobe Scan works, as I know a lot of people use it. But that's not the only one that's out there. Make sure it's safe. Do your own research and download something good. Okay. Okay, so we've taken care of these two. Now let's just do the first one, which is just kind of a combination. We got two numbers that we have to add and they're fractions. And then we've got to multiply that by 3/4. And we haven't done a multiplication yet. Well, actually, we kind of have here. Let's do it. We got 2/3 plus 5/2 times 3/4. Well, I'll just make myself a note. For the 2/3 and the 5/2, I've got to leave myself to multiply each of these by something, so I'll have the same denominator. Now I could multiply this by 10 and this by 15 and get a common denominator of 30. Okay, but I don't want to do that. I want to use a smaller number if I can. And it turns out I just have to multiply this one by 2/2 and this one by 3/3. Again, we want to see that step and then multiply by 3/4. So now that gives me 4/6 plus 15/6 multiplied by 3/4. Okay, 4/6 plus 15/6 is 4 plus 15/6. And we're multiplying by 3/4. And 4 plus 15 is 19, so we have 19/6. We don't need the parentheses anymore. That's times 3/4. Okay. Now you got this thing that allows you to cross out the 3 and cross out the 6 and write a 1 here and a 2 here. I really don't like that very much because people tend to do something sort of like that when it doesn't apply. But if you're doing it right, that's fine. Okay, so I'm going to multiply 19 by 3. I'm going to write it out. 19 times 3/6 times 4. That equals 57 divided by 24. Now that reduces. Okay. So I'm going to do the prime factorization of 57 and the prime factorization of 24, so I don't have to do as much work and guesswork to figure out what works. I know darn well 57 is divisible by 3, and everybody knows that 24 is. The people shake in arithmetic, overuse of calculators. So let's just come over here, make it a little window. 3 goes into 57 19 times. Now, 2 doesn't divide 19, 3 doesn't divide 19, 5 doesn't divide 19, 19 is prime. So 57 is 3 times 19, and 24 didn't leave myself room. And I kind of knew that when I started, so I don't know why I kept going, but I did. I'll put the 24 way down here. Divide that by 2, we get 12. Divide that by 2, we get 6. Divide that by 2, we get 3. So 24 is 2 times 2 times 2 times 3. Now write it 3 times 2 times 2 times 2. We usually do the smaller numbers first. And since I've got a 3 here, I want to match up with this. And that's 3 divided by 3 times 19 divided by 8 which is 1 times 19 divided by 8, which is 19 divided by 8. Well, there's a rule for cancellation fractions. If it's a factor of the denominator multiplied by all the rest of the denominator, factor of the denominator and a factor of the numerator can be canceled. Okay? And here's the reason why, because we can write that factor divided by that factor. This over this is the same as this times this. And this is just 1, so we're left with this. You really should understand that because people generally learn to cancel pretty indiscriminately. And I see a lot of errors in cancellation, not following the rules. Okay, so I don't like to talk about cancellation. We just talk about, well, you got a 3 in the denominator, 3 in the numerator, and it's all factors, no pluses or minuses. So I can separate it like this. Indisputably, this equals this, and that allows this. If you can't do this, you're taking a chance. But if you do the rules, know what a factor is, you're all right. Okay, well, anyhow, that's it. Now, one of you handed me some work there. It looks pretty good. Trying to figure out. We can't talk all. Yeah. Somebody out in the hall trying to talk to me. We got to put an end to that. Okay, somebody came up with 171 over 72. Okay. But let's do prime factorizations. Here's 171. I know I can divide that by 3 because I can divide 180 by 3. And this is going to give me 57. Okay, well, already I'm down to my 57 there, so things are looking pretty good. Okay. Then I divide 57 by 3 and I get 19. So what I've got is 3 times 3 times 19. And 72, I divide by 2, get 36, divide by 2, get 18, divide by 2, get 9, divide by 3, and we get 3. So that's 3 times 3 times 2 times 2 times 2. Might be a little hard to read, but you see I've got an extra 3 in there, right? But this 3 divides this 3, and this 3 divides this 3. And you still get 19 over 8. Now, what you did was you used a bigger common denominator than was necessary, but you still got the right answer. You know, that, at least up to simplification. I mean, what you got was totally equivalent to this. It's just that this is a simpler form, and you'd rather look at this than that. Okay. So that's the whole reason for reducing things to lowest terms. It makes them easier to deal with and easier to understand. Okay. So I think everybody is okay here, but I think some of you ought to practice some more problems, do them without letting artificial intelligence tell you what the answers are, what the steps are. Do your own steps, even if they're wrong, send them to me so I can tell you, yeah, I think you're doing okay now. All right, do several of them. You can go back to your homework and redo those problems, do another version for practice, or you go to the half credit page. That's enter the information for the half credit page. Most people haven't enrolled themselves, but most people are getting the homework done, so haven't had the occasion yet. Fair enough? But you go to the half credit page and do it without looking at anything. review this, make sure you understand operations and do it. Because again, well, this is an example. And you don't have to know how to do this. No numbers. Can you do it? Well, what do you think the common denominator is? Don't say, just give it a little thought. What's the common denominator? Okay, so I'm going to say your common denominator it's b times d plus e. If you multiply your denominators, you always get a common denominator. Okay, so you're going to write this as a over b. Now you got b in your denominator. What else do you need to get this? Well, you need d plus e, right? So you're going to have d plus e. Now, if you got d plus e in the denominator and you don't want to change the value of this thing, you better have a d plus e in the numerator. So you're really just multiplying by 1 and not changing the value of your first fraction. Okay. And then you have c over d plus e. And what do you need to multiply by in order to get the common denominator? B times d plus e. Well, you better multiply by b, which will give you b times d plus e. But it better be b over b so you don't change the value. So we're doing the identical thing that we did with the numbers. Do you understand somewhat why I want you to write out all the steps with the numbers? Because when you get to this, you have to know those steps. Otherwise, you're going to get very confused. Okay? So you really want to reinforce the steps. And then we say, well, then by the rules of multiplication, that's a times d plus e over b times d plus e plus, I'll write bc. C times b is the same as b times c. And I'll usually write them alphabetically. And I'm going to put the b out in front here. Because again, it doesn't matter in which order you multiply this and this. So that equals a times d plus e plus bc over b times d plus e. And at this point, you're probably starting to go blind. But what have I done? I've just said, well, I got the same denominator. So I got this numerator and this numerator added together. Then I multiply a through the d plus e. I get ad plus ae. That's just distributive law. We haven't talked about it yet, but hopefully you're familiar with it. If not, it's not difficult. Anyhow, there we have AD plus AE plus BC. Okay, and all these steps are identical to the steps you use if you write out all the steps when you do the numbers. And you're going to want to do that so that when you get to this, you don't go blind. Okay, because they get a lot more complicated than this. That's why we start with fractions. Because first place people fall flat in their faces when we start doing fractions with symbols. And it's because they don't understand fractions. Okay, so be sure you understand fractions. You're well on your way. Key is write out every step. You're probably familiar with this, especially since you've done the homework in order of operations with fractions. That's just kind of a summary. And just to illustrate what that means, let's say we got 2 plus 3 squared squared plus 3 times 4. What's the first thing we're going to do? Well, you look at it and say, well, I got to square this, but before I square this, I got to add these, right? Because we do parentheses first. So whatever's in parentheses, it's pretty common sense. You're probably used to it. You do that before you do anything else. So in parentheses, you've got an exponent. So you got to do that exponent. So you're in parentheses and you've still got to follow the order of operations to simplify whatever's in parentheses, right? So we got to go to exponents and do that. There are no products or quotients, but we have a sum. You're adding 2 and 9, so we get 11 squared plus 3 times 4. Well, 11 squared is 121. And just doing one operation at a time. We then multiply the 3 by the 4, that's a product. And then we can do the addition and we get 133. Now, sometimes it can get downright ambiguous. So you're going to see a number of expressions. Open Math will explain this to you. It's something I think that you're probably fairly familiar with, but you want to be sure that you're doing it right, because some expressions can be a little bit tricky to interpret, okay? So I'm going to leave it to Open Math to get you up to speed on that. If I find you need more than that, we'll do some more. But I think you'll be okay with that. People usually do pretty well with order of operations. Now, I think the next thing is one-step equations, but let's just make sure. Okay. Yeah, we got one-step equations and we got proportions. A one-step equation is like 5x equals 7. Now I'm just going to throw that out. Can you solve that equation showing me your steps? Okay, so we got 5x equals 7. Now I'm going to do a different one before I do this one. No, I'm going to do this one. Okay, 5x equals 7. What can I do to both sides to isolate x? What could I do to 5x? What arithmetic operation could I perform with 5x in order to just get x? Well, if I divide 5x by 5, what do I have left? Show me with your fingers. Not quite, but close. Well, we're going to divide both sides by 5 here. If I divide 5x by 5, I don't get 1. What do I get? It's x. 1x. Okay? So what this is 5 over 5 times x. And we could even write it as 5 over 5 times x over 1, since we know to multiply numerators and denominators, right? Now, you're not going to want to write out all this, but I want to convince you that this is what you have to do. 5 over 5 is 1, and 1 times x over 1 is still 7 over 5. And 1 times x over 1 is x over 1, and x over 1 is x, so we end up with x. equals 7/5. I kind of recommend that you write out this step so you can emphasize why it works, because there's a strong temptation to divide by 5 or whatever the number is when you're not supposed to, and it'll show up if you write out this step. You don't necessarily need to write this one. You just kind of skip from this one to this one. So I'll kind of put this step here in light parentheses. But I prefer to see these 4 steps at this point of the course. Okay? It'll save you trouble in the long run, and it takes about 3 seconds to write it out. It takes a little more than that. It takes a little effort to think about writing it out, but that's the learning process. Okay. So that's how we solve this problem. Okay. So let's say now we have 2x plus 3 equals 12. What can you do to both sides to isolate x? I'll give you a hint and I'll explain why you don't do it. You don't start by dividing both sides by 2. Because if you divide both sides by 2, you've also got to divide that 3 by 2, and all of a sudden you got a blame fraction to deal with. If you can avoid dealing with fractions when you're solving equations, except maybe at the very end, you're better off. So I'll try to emphasize that idea. So 2x plus 3 equals 12. What would you do to both sides? How would you solve that? Okay, well, put it in this context and everybody got it, I think. Unless, some of you write kind of faint, and maybe I was thinking I saw what I wanted to see, but I think I saw it in every case. Okay, so what people often do here is they put a -3 here and a -3 here. And they get 2x equals 9. Okay? And the rest is very simple. Well, that's pretty much what open math teaches you to do and everybody else, and I don't know what's the matter with them, because it's very easy to make this mathematically valid. This is not a mathematically valid set of steps. If you put an equal sign in here, it becomes mathematically valid. So I think the whole mathematics teaching community either knows something that I don't, which undoubtedly I guess they do, but not in this case. You're adding 2 equations, okay? You don't just write a -3 here and a -3 here and get this, because then what do people do? They start putting a -2 here and think they're going to get an x, okay? Matter of fact, this is valid because you're adding the left side of this equation to the left side of this equation, and you're going to have a 3 and a -3. It's going to give you 0, right? And you add the right-hand sides, of course, you get 9. There's another step that I would like to see that will do you some good in the pretty near future. And that's where you add the 2 sides. You get 2x plus 3 minus 3 equals 12 minus 3. This is the left-hand side. You get this and add the right-hand side of these 2 equations to get this. It's as easy to do as what you've been taught to do. Has anybody ever been taught to use an equal sign there? Maybe you have. I'm sure there are other people out there that figured this out, other teachers. But I don't think open math uniformly does. Correct me if I'm wrong. Okay. If they're uniformly telling you to write down that equal sign, well, then you should. Now, does anybody tell you to do this? maybe, maybe not. But that's what's happening. And then you can simplify. And you get 2x plus 0 equals 9, which is the same as 2x equals 9. And then you can do what everybody did. 2x divided by 2 equals 9 divided by 2. I recommend you write this as 2 over 2 times x over 1 equals 9 over 2. So you can see that this is 1 and this is 1, and this is x equals 9 over 2. That's extra steps, but these one-step equations are short. Instead of being able to write out your answer in 30 seconds, it might take you 45. Okay? And it's more detailed than you want to go to when you get into more complicated equations. But I recommend that you write them out in this form. Okay? Now there's another one, and this one tends to escape people from the first part of the course to the last. One of my big conundrums. How about you have x over 5 equals 3/4. Let's see what you do with that one. You did real well in the last one. First one, you needed a little refresher, but I think you're good now. You know, it might not even fit. Well, okay, that's extraneous. Filing cabinet suddenly appeared back there. Okay, and I want it, and I asked for it. Okay, x over 5 equals 3 over 4. There's your equation. Okay, what do you do to both sides? There are a number of possible steps, but I'd multiply both sides by 5 because I know if I multiply x over 5 by 5, I'm going to get x. Now, how am I sure of that? Again, I recommend you write this out. This takes a second. Just to emphasize that we're multiplying fractions and so forth. Make everything a fraction, okay? Now, this is equal to this. Because if I multiply denominators, I get 5, and the 5 is a numerator. It's multiplied by x. There's actually another step, but I'll leave it off for now. Anyhow, I get x equals 5 times 3 over 1 times 4. X equals 15 over 4. Okay? Multiply by that denominator. Well, here's another one. What do you think you're going to do with that one? What do you think the first step will be? Let's kind of throw this open for discussion, see what people have to say. Okay, now I got a couple suggestions here what to do. One is find a common denominator and use it. Okay. Common denominator would be 12. Okay. And you could put everything over 12. Okay. And that would not change the solutions of the equation. And in fact, in 2 steps, that would do just what I'm going to advise you to do in 1 step. Okay. So it would not be a bad thing at all. Another, multiply everything by 3. That gets rid of the denominator here. Of course, that still leaves you a bunch of fractions. I had 12 over 2. That was kind of ignorant. Because 12 over 2 reduces to 6. I'm going to change that. I want that to be 13 over 10. I think I was intending to write something else as a denominator when I wrote the 12. Anyhow, little brain freeze there. Okay. So if you multiply both sides by 3, you'd have x, but then you'd have to deal with fractions. Okay. So the magical thing that you can do is notice the common denominator is 12, and that is the least common denominator. You could use any common denominator, but the least common denominator gives you smaller numbers and they're easier to deal with, so you want to. Okay. The least common denominator is 12. So we multiply both sides by 12. Meaning we write then 12 times the quantity x over 3 plus 5/4. Now multiplying 12 by the whole left-hand side, not just by the 12 or the x over 3, right? The whole left-hand side. And then multiplying 12 by the right-hand side, we have this. Now, what's 12 times x over 3? Well, we don't know, we don't care. We just write mindlessly 12 over x minus 3 plus 12 times 5/4. Applying one rule at a time, which is distributive law of multiplication over addition. Okay? I multiply 12 by this sum. I've got to multiply 12 by the first term, and I got to multiply 12 by the second term. And then I got 12 times 13 over 2. I could simplify that right now and just try to concentrate on making sure everything is multiplied by 12, and I can see how everything is multiplied by 12. Then, writing out all steps, I'm going to do 12 over 1 times x over 3 plus 12 over 1 times 5 over 4. Now, what you might do, and it's not wrong, it's kind of optional whether to write the step out like this, but if you're making mistakes that would be corrected by writing it out like this, I think you ought to be writing it out like this. But 3's in the denominator and the 12's in the numerator. So I can divide the 3 into the 12 and gives me 4. So I have 4x here. Does that make sense? I'm going to get that in a minute. And I could divide the 4 into 12 and get 3, and 3 times 5 is 15. I could divide 2 into 12 and get 6, and 6 times 13 is 78. Okay. You know, I said that too fast for you to absorb it. I'm just saying we can skip this step if we're careful. But writing out this step shows us why this thing works. Now, I can rewrite these with the 3 as a denominator on 12 and the 1 as a denominator on x. The reason I can do that is 12 times x is 12 times x, and 3 times 1 is the same as 1 times 3, which is 3. So really I have 12x over 3. Okay? So if I multiply the numerators and denominators here, I get the same thing as if I multiply them here. Same thing here. I multiply the numerators and denominators of these fractions. I get the same thing here. And same thing over here. Now, if you don't understand that and you want to just come up to here one way or another, I'll just make an arrow from here. This gives us 4x plus 3 times 5 equals 6 times 13. And that's what I get if I just divide the 3 into the 12. The 4 into the 12 gives me 3. The 2 into the 12 gives me 6. Okay. Seems tedious to write out all the steps, but it gives you better insight. If you wrote out these steps, you would have the same thing because 12 over 3 is where that 4 comes from. So just skipping from here to here and not doing these 2 steps, if you do it right, gives you exactly the same thing that I got here when I just divided 3 into 12, 4 into 12, and 2 into 12. Okay. But think about why I would write out these 2 steps to make it mathematically rigorous. And by making it mathematically rigorous, I mean that if you understand these 2 steps, then you're, and really understand them, then you're never going to be confused about what you do from here to here. You might not be confused anyway, just make sure you're getting it right. And if you aren't, think about what I'm saying. Okay, well, that gives us 4x plus 15 equals 78. And I'm going to put 3 dots for steps that you should be able to fill in. And you're going to get x equals 63 over 4. Now, those 3 dots don't mean you should skip all the steps. That means you should write out all the steps in between, similar to what we've done before. Okay, now this might not seem all that simple, but if you do it a few times, it is. So you need to practice it, and you need to get it into your head. But what you're really doing, multiplying 12 by x over 3, 3 is going to go into 12 4 times. So you're not going to have a fraction here. 4 is going to go into the 12 when you multiply 12 by the 5 fours, and you're not going to have a fraction. You notice that what I end up with here is an equation with no denominators. Okay, so you never see a fraction again until your very last step. That makes sense? Well, that's one that I try throughout a pre-calculus class to get people to know. When you have an equation with denominators, you multiply by a common denominator. Preferably the least common denominator, but any common denominator will do it. If you don't use the least common denominator, you just got a little more stuff to write out. Okay? Okay.